In this video, we're going to talk about graphing quadratic inequalities. So right away, we have to make sure we recognize what inequality symbols we have and what they tell us. If we have a less than or a greater than symbol, it tells us our parabola is going to be a dashed parabola. If we have an or equal to symbol, that means we're going to have a solid graphed parabola, just like it would be if it was equals. You have to know the difference between less than or greater than, otherwise you're going to end up with an answer that is the exact opposite of what it's supposed to be. So first, remember when we graph parabolas with equations, we found the vertex and then utilized whatever table style we wanted, whether it was an XY, AY table or just a traditional XY, plug in X, see what Y equals, to find 4 more points at least, and then put them all on the graph to get our parabola. We can always check our answers by taking the order pairs from our graph, plugging into the equation to see if it worked. Those ideas still work now that we have an inequality, but now we have 2 extra steps. The first step is making sure we know if it's solid or dashed. The second one is using a test point to determine where to shade. Right away in number 1 here, I just look at the inequality symbol and I can immediately tell that this is going to be a dashed parabola. I'm not going to do anything with that until I actually get to connect some dots, but I know in the back of my head that this is going to be dashed. Now, before I can graph this, I need to subtract 3 from both sides. The purpose of subtracting 3 from both sides is to get all of the stuff on one side of the inequality with the y by itself on the other. This is the same as when we had y equals or f of x equals. We get y by itself, everything else on the other side. Now I get to determine what form I have, so I know what steps to take. I'm either going to have standard form, intercept form, or vertex form. I'm hoping for vertex form, but in this case, I get standard form. So when I have standard form, the first thing I find is the axis of symmetry. That's always going to be at x equals negative b over 2a, which in this case, negative b, negative 4 is a positive 4. 2a is 2 times 2. That's 4. So we get x equals 1 for the axis of symmetry. The reason we find that is to plug that in. 2 times 1 squared minus 4 times 1 minus 3. I'm essentially pretending that inequality symbol is an equals. So think of that as equals y. 1 squared is 1 times 2 is 2. Minus 4 times 1, that's minus 4. So 2 minus 4 is negative 2. Minus 3 is negative 5. This gives me a vertex of the 1 that I plugged in, the negative 5 that I found. So 1 to the right, 1, 2, 3, 4, 5 down for my vertex. Now I'm going to do an XY, AY table. I'm going to do negative 1, 1, negative 2, 2 for x. The y portion, I just square those numbers, so I got 1, 1, 4, 4. My a value in this question is 2. So I'm going to take all the numbers I just found and double them. So I've got 2, 2, 8, 8. Now I don't care about the y column. So from that green dot, I'm going to go left 1 up 2, and also right 1 up 2. From the green dot, I'm going to go left 2 up 8. I'm also going to go right 2 up 8. And that's basically where, excuse me, in the last chapter with equals, we would just connect the dots and move on. Now this is where I'm come back to the dashed portion. So I'm going to come through, and it's kind of tricky to draw a dashed parabola. So I'm not going to expect a perfect parabola by any means. Like that kind of curved out already. Oops, sorry about that. Try your best to get it parabolic shaped. There's nothing wrong with drawing full solid, coming back with an eraser to make the line dash. There's nothing wrong with that. Works just the same. Most people remember to do solid or dash. The thing that people forget to do next is a test point. In Algebra 1, when we had equations and inequalities that were linear, you could usually just kind of look at the symbol and know what side to shade on. Now that we are in parabolas, it's not always quite that simple. So when you have a test point, you pick something that is either inside or outside of the parabola. When I say inside, I'm going to be like this area is inside. My general rule, it's not really much of a rule, is a habit. 0, 0 is always a great number, but I actually like to take the x value from the axis of symmetry, comma 0, if I can. And it might seem weird, but the reason why is I have to plug this value in. So if I plug it into what I had in black over on the left side there, 2 times 1 squared minus 4 times 1 minus 3 is greater than 0. I have to redo this work. But I already did that exact calculation, and I found that I got -5. So is -5 greater than 0? Well, no, this is false. So my test point inside of the parabola was false. That means I shade outside of the parabola. Okay, so I picked the test point 1, 0 for efficiency. I very well could have picked 0, 0 because that is definitely inside the parabola. But depending on the form that you are given, you might actually have to do extra work. So in standard form, that would have worked fine because the 0 would cancel out the x squared and the x term. You'd have -3 greater than 0. You get the same thing. But if it's in not slope intercept form, ignore that completely. If it's in intercept form, so we have the factors, you would have to actually do some multiplication to figure out what's going to happen. Where by using the axis of symmetry, you already know the vertex value, so you don't have to redo the work again. So that's kind of an advantage of that. All right, so in these problems, you need to have solid or dashed parabolas, depending on your symbol, and you need to have shading, otherwise you will not get full credit. Have a great day, everybody.